You guys are still doing integrals, right?
Yeah.
Okay. Shoot, sorry. Okay. Let me first talk about, before I get into answering specific questions. I think it's better if we talk about what an integral is, or what's the difference. First of all, there's a difference between. Sorry, let me get my drawing tablet working before I keep talking. Okay. 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 So the difference between a. Sorry, my desk is a mess because I've been uh fixing it. It was broken for a little bit. So okay. Shoot. Come on. Okay. Um. So. Okay, that works. Okay. So let's start with a problem. All right. Let's say I have some. Oh, not like that. I'm gonna still talk about what antiderivatives are first, right? So let's say we have a curve like this, right? And we want to find the area, let's say from 0 to like 2, right? What we can do is we can divide it into rectangles, right? So let's divide it into 2 rectangles, right? And we can take, let's take the y value at each of these, and let's make a rectangle out of it. And if we add up those, if we add up those rectangles, we can get like an approximate area for under this curve, right? But the problem is, uh, approximation isn't good enough. So why don't we do more rectangles? Why don't we do 4 rectangles? 1, 2. So that would be 1. That would be 3 over 2. That would be 1/2. If we do 3 rectangles, uh, we get a better approximation, but it's still not perfect, right? But we can represent what we're approximating by saying, let me just finish this. Instead of just taking, we can use limits to, instead of taking a definite amount of rectangles, we can say, why don't we just take an infinite amount of rectangles, right? So we're just taking an infinite amount of rectangles, right? And the way we say that is, let's say instead of 2, let's put a over here. We can say the limit. What's the width of each of these rectangles? Let's say there's n rectangles. What would be the width of each rectangle? If they're divided equally?
Or dx.
No, because we're dividing it equally. It would be a over n, because we have a and we're dividing it into n rectangles. So each rectangle would have a a um a length of a over n, right? And if we multiply those rectangles by the height, which would be uh which would be the this would just be f of, let's say, some constant k, a over n, right? And to represent that, we can say limit a over n times the infinite sum, infinite sum from k starts at, let's say, 0 to k goes to n minus 1. And the reason it's n minus 1 and not n is because we're taking the y value of each of these over here. So the last rectangle would be right before a, right here, which would be k. It would be n minus 1 times a over n. So it would be the infinite sum of k, from k equals 0 to k equals n minus 1 of k a over n, right? And so you can see this, right? We start at 0, so we take this rectangle, we do the area of this rectangle, right? 1a over n. And then we take the area of this rectangle, and we just do that until we go all the way to n minus 1 over n, right? Another way to represent this is we can, and this is the limit as n goes to infinity, right? As we get infinite rectangles. So another way we can represent this in terms, another way we could represent this, instead of writing this out every time, we can call a over n dx, and we can multiply it by this over here, which would become, we use this symbol, right? It's like, if this is a sum, this is like a smoothed out sum. It's an infinite sum, right? So we call that the integral of f of x from 0 to whatever we chose. From here, from 0 to a, right? And we can write this with proper notation by saying 0 to a f of x dx. Does that make sense? What I just did there? What I did was, I turned this, okay, I just see that a lot of people have joined, so I'll just quickly explain what I just did. I essentially was starting off, what if I wanted to find the area under a curve? And then what I did was, okay, I could split it up into rectangles, but that's not good enough, so why don't we split it up into infinite rectangles, right? And if we want to find the area from 0 to a, we divide it into n rectangles. The width of each rectangle is a over n, and the y value of each rectangle is f of k times a over n, where k is just some number. It's the number rectangle that we're on, right? So this is the k rectangle. This is you know what I'm saying? So no, rectangle number 1, rectangle number 2, etc., etc. And I could write it like this, but an easier way to write it is with integrals, where we say that a over n is some really small value of x, or dx, right? Some really small change in x, times infinite sum. That's where the integral symbol comes out. It's kind of like a smoothed out symbol for, it's a smooth out sum symbol. So that's what the integral symbol is, and we go from 0 to a. And that's where the integral comes from. So first and foremost, the integral is the area under the curve. This does not mean the antiderivative yet, because we haven't proved that, right? All this is the area under the curve. So how do we prove that that is equal to the antiderivative of f of x? Well, is it okay if I erase this? Does anyone still need it? Okay, I'll erase it then. So let's say we have, let's just use the same curve, right? And we have some function a of x that's basically the area from 0 to x of this, right? So that's, and then let's say we want to do x plus h2, right? We could say that so the area of x minus, actually, wrong way. This is a little convoluted, but it'll make sense. So I haven't done this in a while too. So area of x plus h minus area of x is equal to this area over here, which we can say is the average value of x in that range, times h, because that's the distance here. So would you agree with me that the average value, which is like over here, right, times the base is equal to the area of this here is equal to this area? That's what the average value is, right? So that expression is true. And we could say that, and if we divide both sides by h, we get a of x plus h minus a of x over h is equal to. Now what if we take the limit of that as h goes to 0? Well, the limit as h goes to 0 of a of x plus h minus a of x over h is equal to, and what does this turn into? This, yeah, actually, let me ask you guys, what is, if this is the average value, if these get really, really close together, right, what does the average value basically become? If they keep getting closer and closer together, what does the average value basically become? And remember that this is moving towards x. They aren't both moving, just this one. Does anyone have any idea? It approaches, the average value actually approaches f of x. It goes from being the average value to just f of x. And the reason for that is, if the lines are so close together, right, I'm zooming in a little bit. Let me zoom in here. Right, let me zoom in. If the lines are so close together, the average value just essentially becomes the value at x, right? And so this turns into f of x. And what does this look like? Actually, yeah, it does look like the derivative. And does it make sense why the average value turns into f of x when you take the limit as h goes to 0? It turns into the just f of x when you take the limit, which is what we did to both sides. Does that make sense? Is there any questions about that? Because I always thought that was pretty cool. Okay, well, if there's no questions, then we could say that the derivative of the area function is equal to f of x. So, and if we also know that area is equal to f of x dx, right? From let's just say it's equal to that, right? So if we take the antiderivative of both sides, we get, so that's area of x. Sorry, this is a little convoluted. So so that means the area of x is equal to the antiderivative. And since we also know, so if the area is equal to, let me say anti of f of x, and area of x is also, so if these two are true, what has to be true? I think we learned this in like IM2. It's some kind of proof property. If A is equal to B and B is equal to C, then A is equal to C, right? So that so by that transitive property, which I think is what it's called, you can say that the antiderivative, so the antiderivative of f of x is equal to the integral of f of x dx. So that's how we prove that it is the integral, or that the antiderivative is the same as the integral. And it also makes sense conceptually, because if you think about it, right? Is it okay if I erase this? And the only reason I'm teaching you this is because this is the order that Mr. Shao taught us in. He taught us Riemann sums first before he showed us integrals, and that made doing integrals a lot easier. He'll probably show you this later, so if it doesn't make 100% sense, that's fine. I just wanted to share it. But anyways, because I'm not sure if he'll teach you it. You guys might be running out of time or something. Maybe that's why he skipped it. But anyways, does this make sense before I erase it? Okay, I'll erase it then. So this makes also conceptual sense. Because if you think about it, right, let's think about just velocity or something, right? If we have velocity, right, and this is velocity of x, what is velocity?
The derivative of position.
Yeah, so you can think of it as a change in position, right? So if we add up changes in position, right, we're gonna get how far it moved. Like wherever we started adding up, it was at some place, and by adding up all these changes in velocity, we're gonna get how far it moved from that original point, right? And that's also why, right, if we take the antiderivative of this, right? So if we take the integral of from, let's say this is x to y. Actually, that's a bad. Let me change these variables. I'm going to say from a to b, right? That is also why if we go from a to b, that's equal to the position in a minus the position of b. This makes no sense, right? Initially, like it makes no sense. But if you think about it, right? If you add up these positions, that'll be shown in the position curve, right? A, let's call this p of x, right? This is a, and this is b, right? So if you subtract these, you get how much it moved, which is the exact same as this. We're adding up changes, right? So that's why we take, and oops, I flipped these. That's b and that's a, right? This change can also be found by adding up the rectangles. That's why these are equal. That's why this is true. Does that make sense? Or I can try explaining it a little better, but
So definite integral is just like the change over that interval.
yeah, from a to b, it's the change, right? And that's why that's also, and it makes sense, right? Why we subtract the top from the bottom, right? It feels like some kind of random rule, but the reason it works is because if it's at 5 here and it's at 3 here, then the change is 2. And if you added up all these changes in velocity, you'd also get 2, right? So that's the reason that's true. Does that make sense? Did that answer your question or clarify things a little better? Okay. All right. So that's that is integrals. Integrals are first and foremost a the area under a curve, right? Right? This is dx. That's the length of our tiny rectangle, and bx is the height of our rectangle at that point. So we're just adding up little rectangles going from A to B, right? And if and the reason that this is true is because if you add up these changes, it should obviously reflect in our quote unquote position function, right? When we subtract here from here, because it'll show us the change as well. Okay, so I think that's the simplest way I can explain integrals. Honestly, that's pretty simple. That's all integrals are really. And okay, so now we can probably get to like specific questions if you guys have them. Do you guys have
I had a
questions?
couple of questions.
Okay.
Let me post the picture of the worksheet in the server.
Yeah.
You can follow along. I'll place it in homework help.
Yeah, that should work. Okay, I see it.
Yeah, so could you go over starred ones, number 23, 24?
Okay, 23 and 24. All right, let's do 23 first. So 3 minus 6x over x minus x squared dx, right? Okay, well, I'm thinking that this is 1 over u du if we do u sub, and u is equal to x minus x squared, du is equal to 1 minus 2x. How do we get a 1 minus 2x, right? We can pull out the 3, and now this becomes 3, 1 over x minus x squared. That's 1 over u, right? Times 1, oh, and there should be a dx here, actually, because we took the absolute derivative of both sides. So that's equal to 1 minus 2x dx, and that's our du over here. So that means that this is equal to 3 times ln u, which is 1 over x minus x squared. We can, this doesn't look that pretty in my opinion, so I'm just going to put a negative ln x minus x squared. And actually, I'm debating, should these be absolute value symbols or not? Let me think about it. Because if we, can this ever be negative? The domain, does this extend to negative x's? If it does, then there does need to be absolute values. Can you plug in a negative x here? Yeah, you can. So this actually, these need to be absolute values, because the domain of the integral obviously has to be the same, or I think the same or smaller than the derivative. Or the same or bigger than the derivative. So that's your answer. Does it make sense why I put absolute values there? It's
yeah, but like the answer says it's just 3 ln x minus absolute value of x minus x minus 1.
x.
And it's a positive 3, not a negative 3.
Okay, 3 ln absolute value of x minus 1.
Yeah, and the x minus 1 is in parentheses. Plus c.
Oh, plus c. Yeah. Plus c, like that. That's what it is.
Yeah, that's what the answer is.
Interesting. Okay, I think it's Yeah.
Can I put in the server like what I got and I worked for it?
Yeah. Were you able to get his answer or
something similar? I think it just like slightly off, but I don't know what I did wrong.
okay?
Yeah.
Let's see it.
Yeah, posted in homework.
Okay, so 3 minus 6x u du. Okay. Oh, okay. First of all, yeah, I did something wrong. This is ln of u, and u is x minus x squared. So that's that. And this is positive. So I'm getting your answer. I don't see, honestly, I don't see how he could have gotten how this answer is correct. I feel like it's some kind of mistake. Yeah, I think you're right.
All right, cool.
Yes, sometimes he has answers wrong, so I don't know. It makes sense if the process works. I think you're probably right and he's probably wrong. So, all right.
Okay.
And another thing you could do is always take the derivative and see if you get the same thing. So let me just do that real quick. X minus x squared plus c. If we take the derivative, that's 3 over x minus x squared times 1 minus 2x, which is 3 minus 6x over x minus x squared, which is what we had. So this is correct, unless his answer is some weird manipulation of it, which I wouldn't worry about because this he would give you credit for it anyways. Unless that's the case, he's probably wrong. So okay, and then the other one was number 24. Okay, all right. X, so 24. So the integral of x times x cubed minus 8x squared to the 7th times 12x minus 64 dx. Okay. What I would do is
would u be the inside function, so it'd be like x cubed minus 8x squared?
yeah, I would say this is u, and so if we say that's u, what's du? Du would equal 3x squared minus 16x dx. Okay. Well, here this could, if we factor out a what is it, a 4, we could get that, but we're missing an x, but we have the x over here. So if I move the x into here and then factor out a 4, I can get 4 x cubed minus 8x squared to the 7th times 3x squared minus 16x dx. So what I did was I moved the x into it, and then I pulled out a 4. And now it's u to the 7th du times 4. So that would be 4 u to the 8th over 8, which is x cubed minus 8x squared to the 8th over 2 plus c. So that's that one. Does anyone else have any other questions?
Could you do 14?
14. Okay. I think I might have been looking at this one earlier.
This one, the answer key had 32 in the denominator.
Oh, 32.
Wait, can I send a picture of the answer key?
Yeah, that would be helpful. Another way, I mean, okay, let's take the derivative of this and let's see. I'm assuming you get the answer. Times 7 over 8 over 2 times 3x squared minus 3x squared minus 16x, right? Now if this becomes a 4, so if we put the 4 into here and then pull out the x, right, we get x cubed minus 8x squared to the 7th times 3, shoot, I pulled out the 4. Did I? Or no, I put in the 4. So 12x minus 64, and then have the x. So that is the same as this. It works a little messy, but that's the same as that. So my answer should be correct. So that might also just be another wrong answer. Okay. Any other? I think someone said 14. 14 looks interesting. We could do that one.
Yeah.
Okay. So let me.
You said u as 1 minus cosine 2x.
Yeah, that's one way to do it. That's probably the fastest way to do it.
So then would du be
What's the derivative?
just sine 2x.
Negative sine 2x. So you need to put in a negative and take a negative out as well.
But cosine, the derivative of cosine is negative sine, right?
Yeah.
So
Oh
then
shoot.
negative
Yeah, it
cosine
is
is
sine 2x.
sine.
Yeah, my bad. Yeah. Okay.
Sine 2x dx.
Yeah, so that one's pretty easy. Oh, but there's a 2. The derivative of that is 2 cosine 2x. So you need to put in a 2 and pull out a 2.
So it'd be like du equals 2 sine 2x dx.
Yeah.
So then you get du over 2 sine 2x equals dx, and you just start plugging it in.
Yeah.
So then you get sine 2x over u to the 1/2 times du over 2 sine 2x, and then you put up 2, which is a 1/2. So right.
Yeah.
1/2 sine 2x u to the 1/2 times du over sine 2x, and the sine 2x cancels, right?
Let me see.
Yeah.
So 1/2.
I'll show it my workout.
Okay. 2 times 2/3 times 1/2. So that becomes 1 minus cosine 2x to the 3 over 2 over 3. That's what I got.
Let me see if
Oh, plus C. Shoot.
I got 1/2. Let me see. Oh. My final answer is 1 minus cosine 2x to the 1/2 plus c.
Okay. Do you want to? Yeah.
What question is this? This one?
I can also, let me just do it out completely so we can compare.
I got it right.
Oh, you did? Okay.
Yeah. You still want to see my work or?
Yeah. Yeah, I do. What you got? 1 minus cosine 2x to the 1/2 plus c?
Yeah.
And that
C,
work? Okay.
Yeah, put it.
Oh, yeah. Shoot. I keep messing up. Yep, that's okay. Yeah, I messed this up pretty bad. Let me u to the negative 1/2 du. So that's u to the 1/2 over 1/2. So 2 times 1/2 from here. And those cancel out. So yeah, you get 1 minus cosine 2x square root. Yeah, square root. I'll put it 1/2 though. Plus c. So yeah, you got it right. That was, I made a mistake there. Okay.
Also, 20 looked a bit weird as well. If you work that.
Okay, 20. Is 20 in the one that N13 sent or?
No, I think it's different.
Okay. Oh, okay. Let me look at it. 20. Oh, that one? Okay. I remember looking at this one. This one's pretty cool. There's probably multiple ways to do this, but the one that looks the most fun and looks the easiest to me is, let's just look at this for 1 second. E to the cosine squared x over e to the sine squared x times.
Could you since you have e to the cosine squared and divided by e to the sine squared, I already my mind's thinking of e to the cosine squared minus sine squared.
Uh-huh.
So then you get e to the cosine 2a.
Yeah. Yep. And then, so that's e to the u, and the derivative of cosine 2x is negative sine 2x. And we almost have a sine 2x here. We just need a 2. So if we put in a 2 and put in a 1/2 out, then we can say sine 2x. But we still need a negative, so let me put in a negative here and put a negative out. So now we get. Also, remember to put parentheses around your whole thing, even in your work. I remember he took off like 50 points on a test out from everyone who didn't do that. So remember to do that. I'm not really sure why we do that. I mean, it makes sense if you're doing like x plus x squared dx, because then obviously this looks like just that. You know what I'm saying? But if it's
So
x times,
put the parentheses.
yeah, put parentheses like this, because that's the only way the distributive property works, right? Otherwise, it looks like you're only multiplying the dx by x squared, which makes no sense when you think about the rectangle thing we were doing, right? So that's why he likes parentheses. Even if there's times here, which technically then it shouldn't matter, you still want parentheses. So just do that. Okay, so that's a negative here. So now we get e to the u. There's a 2 here as well. E to the u du. So it's negative 1/2 e to the cosine 2x. That's the answer. Plus c.
My work's a little bit different than yours. So right now where I'm at, I have like negative 1/2 on the outside, and
Uh-huh.
I have the integral of e to the u times sine x cosine x times du over sine 2x. So I see the sine x cosine x. That's like 1/2 sine 2x. So if you add a 1/2, and then see if you just add a 1/2 and then take it out, so you line and compensate, right?
Yeah.
So then you add a 1/2, so you multiply the outside by 2, correct?
Uh-huh.
So then you get negative of the integral. So then the sine 2x and that cancels e to the u du. Is that what you got?
I got.
So then I got.
I think you might not need to if you turn this. So what you're telling me, I think, is you obviously lied and compensated for the negative, right? But then you did e to the cosine 2x. You turn this into 1/2 sine 2x. So you actually don't need to lie and compensate. You just take it out, right? Here I lied and compensated just because, I don't know. Honestly, I don't know. I just lied and
The answer
compensated.
key said that's negative e to the cosine 2x over 4 plus c.
Over
So if
4. Okay.
So if I added a 1/2, would you just take out would you just take out another half? Then you'd get the answer in the answer key. You get the negative e to the cosine 2x over 4 plus c. Is that how that works? Like if you add something, you just take out that same number out?
Yes, but that's if it didn't already exist. And technically this already existed, right? Because all we did was change the identity. But the thing is, right? So what did he get? He got negative e to the cosine 2x over 4.
Over 4 plus c.
If you take the derivative of that, you get negative 1/2 e to the cosine 2x times, and that's a negative, shoot. Dang, that's a negative 1/4 e to the cosine 2x times the derivative of this, which is 2.
Negative sine 2x.
Oh yeah, negative 2 sine x cosine x, right? Oh, wait. Is that the derivative of that? No, it isn't.
No. I don't. It'd be negative 2 sine 2x. So it'd be negative 4 sine x cosine x.
So that becomes negative 2 sine 2x, negative 4. Oh, okay. So I did something wrong here. So I put a 2 here, and then I said that was, and I took out a 1/2.
So if it already isn't there, when you put something, you take the reciprocal of it out.
Yeah.
Okay, then I don't know where I went wrong, because with what I added a 1/2 to the sine x cosine x, and I took out a 2. So then the answer, I don't know why it's.
Okay. So the reason that you don't need to when you add a 1/2 here, you don't need to put a 2 here. The reason you don't need to do that is because it already exists, right? It's already sine x cosine x is already 1/2 sine 2x. You're not technically adding anything, right? You're just swapping these out. When you add something, that's like what I did here. When I added the negative 2, it didn't already exist there, right? And then I took out the negative 1/2. So that's the reason. Right?
Yeah.
The only thing is, I don't know why I'm getting a negative 1/2 instead of a negative.
So then the sine x cosine x itself, you can convert that to 1/2 sine 2x.
Yeah.
Okay, that makes sense then. Because when you do that, you can pull out a 1/2 because it's already there. So then you get negative 1/4, and then you get the answer.
Oh, okay. Yeah. Okay.
I'm gonna show you my work.
I think I'm fine because I just realized. Yeah. So
Yeah.
the reason, so I put in a negative 2 and I put in a negative 1/2, right? So that gives me this. That gives me this right here. But then I need to put in another 2 and pull out another half to make it e to the u du. So that's why it's negative 1/4.
Yeah.
Whoops.
Okay.
Yeah. That makes sense. Okay. So that's that. Is there any other questions?
I guess 22.
Okay, 22. Let me. Okay, 22. Okay, so cosine inverse x over square root 1 minus x squared dx. Okay, well, we could say this is u du, and then if u is equal to cosine inverse x, cosine u is equal to x. x1 square root. So
But why did you set u equal to cosine inverse? Why would you set it to 1 minus x squared?
the reason I did that is just because I know that it's kind of because if I were to set it equal to 1 minus x squared, then there's not really any way to get a cosine inverse x out of that, right? Versus I know that the derivative of cosine inverse x is square root 1 minus x squared, or at least I think it is. I'm doing it right now.
It's a negative. It's a negative.
Yeah, that's okay, right? So it's kind of just looking ahead a little bit, and it's like, okay, I can what u do I pick so that I can get out the right thing,
Okay.
right?
So it's not like a strict thing. Like it's not always inside a function. It's like what can cancel out more stuff and make the problem easier. Is that a good way of thinking about it?
Yeah. It's really like a puzzle. There's probably multiple ways to do this integral. There's really multiple ways to do any integral, but it's always which one's gonna be the easiest, right? And for me, when I'm looking at this, if I see a path, which the path I see is making this u, so that this becomes part of du, right? Then I would just take that path. So it's looking ahead a little bit. So yeah, it is just
Yeah,
like
okay.
yeah. Okay, so that's u du. So it's just cosine inverse x squared over 2 plus c. That should be it. Let me check. Number 22. Oh, negative. Whoops. There we go.
22. Yeah, that's right. That's right.
Okay.
Cool.
I don't really see. What about number 15? Did you guys figure out how to do that one?
Tempted, but looking at sine 6x, that's just 2 sine 3x cosine 3x, and then the cosines cancel.
Yeah. Okay, that makes sense. Okay.
Beyond that right now, I get why it's 2 sine 3x, but I don't really get what to do after that.
For 15. Are you talking about 15?
Yeah.
Okay, so let me just do it here. 15. So sine 6x over cosine 3x dx, right? The top becomes 2 sine 3x cosine 3x. I think that might be what you're missing, right? You forgot the cosine 3x over cosine 3x dx. So then those cancel out, so you get 2 sine 3x dx, which is sine u du. I need a 3, so let's multiply. How can I turn a 2 into 3? I can multiply by 3 over 2. I can multiply by 3 over 2 inside and then plot a 2/3. So 2/3 cosine, negative cosine 3x plus c. So I think you just forgot this over here. Was that it?
Yeah.
Okay.
I assumed it was cancer, but there's a root in the denominator.
Okay. Yeah. I was gonna talk about why, because there's actually technically some functions you can't take the integral of, and I remember having an explanation for it, but I forgot it. I'll let you guys know next time if I remember what the explanation was. The most famous one is e to the negative x squared dx. You can't integrate this, and it also happens to be the bell curve for statistics and whatnot. I forget why some functions can't be integrated, but yeah, just something to keep in mind.
Does that apply for like number 7?
I mean, if it's on here, probably not, but we can do number 7. Square root x cosine. He'll probably never give you a function that you can't uh integrate, but
Solution says like this one has no solution and it says bad problem.
really? What?
Yeah.
But I think I see a solution. It's cosine x to the 3 over 2 dx, right? Or and then square root. Let me turn that into x to the 1/2, right? So it's cosine u du. U is equal to x to the 3/2. Du is equal to 3/2 x to the 1/2 dx, and we just need a 3/2 here and a 2/3 here. So then it becomes 2/3 sine x to the 3/2 plus c. That should be the answer. I'm assuming there's something weird about this problem. Is it? No, that should be right. Let me see. Number 7, no solution, bad problem. I'm thinking maybe it's a domain thing, because you can't x cubed. So that means x can only be positive, but that also applies. Let me search this up real quick. That should work fine. What was it? It was x to the 1/2 times cosine x to the 3/2 dx. It's probably, is there an integral? Let me see. Oops. Okay, there we go. Whoa. Okay. Interesting. I'm trying to think. That it doesn't make sense that they're, because I just found it, and if I take the derivative, I get sine, that becomes cosine x to the 3/2 times the derivative of the inside, which is so 2/3 times cosine x to the 3/2 times 3/2 times x to the 1/2. So those cancel, and we get that. Okay, I would ask him about this. It seems interesting. I don't know why. Were you able to get it? The answer is like,
I got what you got.
yeah. Okay.
Yeah.
I mean, even Wolfram Alpha is saying it's weird, so that's interesting. I feel like it has something to do with the domain of the function, because the integral has to have the same domain or bigger than the original function. So it may be something due to that.
Right.
Is there something you can plug into? Is there something you can plug in here that you can't plug in here? That's the only thing. You can plug in negative numbers. You can plug in 0. Oh, you can't plug in negative numbers, but you can't into the original either.
Yeah, I guess because one's even, one's like, because like square root, it has to be positive, but then for the cosine of root x cubed, that can, wait, that also can be negative though, right?
Yeah, they both. Are you trying to say that like? Are you trying to say that this?
X,
Oh, what were you saying?
like x can be negative in any of them.
Yeah, so that should be
From
fine,
the,
right?
yeah, no.
Honestly, I'm not sure.
That's alright, I'll ask him.
Yeah. Okay. That's interesting. Okay. Any more questions? I have to think about that one.
Maybe do 16.
Okay, 16. Uh, sine ln x over x. Oh, that's sine u, right? And the derivative of ln x is 1/x, so it's just negative cosine ln x. Does that make sense?
Yeah.
Okay. Okay, so for 18, I guess I can do number 18. He calls it, the method he uses is, he calls it I wonder, which, I mean, you can think about it like that, but you can also think about it like you know how usually when you do u sub you get like u du or something, right? Instead, you can think about it as just the integral of du, right? And so so let me write the original problem first, actually. So it's the integral of 10 to the negative x dx, right? If u is equal to, so I'm thinking it's the integral of du. If u is equal to 10 to the negative x, then ln u is equal to negative x ln 10. So 1 over u du is equal to negative ln 10 dx. So du is equal to 10 to the negative x times negative ln 10 dx. So I need a negative ln 10 here. And I need a 1 over negative ln 10 outside. And so it's just, what's the integral of du? It's just u, right? Times whatever we needed. So it's just 10 to the negative x over negative ln 10. So it's not really separate to u sub. Just like, it's honestly just u sub. I guess it's just students wouldn't normally think about the integral of du, so he just calls it I wonder. But yeah. Okay, that should be. Were you guys able to get the bottom one? 27.
Oh yeah.
It's e to the x times. Wait, what is it? E to the x times e to the x. So it's e to the u du. Okay. Okay, I think there's some new people here. I don't know. Maybe you guys have been here for a while actually, but do you guys understand why number 7 is no solution? Or not number 7, number 15? No, number 7, not number 15. Do you understand why number 7 is no solution? Because I don't. Okay. Because I put it through Wolfram Alpha and it also said whatever. It also said no solution. That's okay. I'm thinking, let me put this through Desmos. Maybe there's like some reason graphically that it doesn't work. Shoot. What was I doing? Oh, Desmos. What do we want to put in? X to the 1/2. Shoot, there's some typos there. Whoops. Come on. There we go. Okay, x to the 1/2 times cosine x to the 3 over 2. Okay, I mean that looks, I don't know, that looks normal to me. I'm thinking about this area wise. Is it cause no, that can't be it. What is, does it let me know where it hits? Is that like 3 pi over 2 or something? Is this like, is that pi over, no, that's not pi over 2. Okay. I don't know. Okay, let me, did anyone ask about it? Or like anything at all?
Oh, because I think the majority of us, the homework for the week.
Okay, let me search up, why do some integrals not exist? Let me see. Okay, can I copy and paste this and just see if someone made a random forum post about it? That does not work. Whoops.
It is like number 8.
Huh?
I mean, is there any way you could quickly do number 8?
Oh yeah, I can do number 8. Okay. So number 8. Let me see. Let me erase this. Yeah, someone asked Mr. Shah about that because even I'm curious because I mean I found something and I took the derivative and I got it, so I don't know. Okay.
What, number 8? I mean, you got number 7.
Yeah, for number 7.
Yeah.
Okay, number 8. Because honestly, that could be some kind of like weird theory problem. Like I could see that being on the theory test or something. Tangent x, secant squared x dx. Well, I can kind of see where this is going, but it's u dv. Did he show you how to do it by parts? Do parts?
No,
He
I
didn't?
don't do it, but
Wait, did he actually not show you how to do parts? I mean, there's probably another way to do
no.
it. Okay, well, another way I would do this is secant squared x is, what is that?
1 minus tangent.
Okay, 1 minus tangent squared x. So then this is tangent x minus, is that tangent cubed x? Oh, wait. What am I even doing? Wait, hold up. It's literally just u du. Right? U is tangent x. So du is,
Oh, wait. Oh my god. Yeah, obviously.
so it's,
Never mind then.
okay. Dang, I'm still thinking about that one. There's gotta be, like, because, okay, I don't know. Okay, anyways, is there anything else? Was there anything from, like, past homework that you guys couldn't do? Because I'm assuming this probably isn't your first integration.
Could you do 30?
Okay, 30. Hold.
It's on a different page.
Oh, here, I see it. Okay. Okay, yeah, we can do this. If y is equal to e to the 3x plus e to the negative 3x to the 1/2, then find dy dx at x equals ln 2. Well, first thing I do is, can you even plug in ln 2? Yeah, you probably can. So I wouldn't worry about that. Second of all, actually, yeah, let's just take the derivative. One way you could do this is by just, going straight to it and doing it, but I feel like if we simplify it, it might be easier. So that would be equal to x to the e to the 6x over e to the 3x plus 1. I think that should be it, right? Is that easier or harder? That might be harder, actually. Yeah, there's no point. Okay, let's just do this the long way then. Let me know if, when I'm taking the derivative, if anything doesn't make sense. Does that make sense? I think that should be it. I'll just plug in ln 2.
Yeah.
So 1/2 e to the 3 ln 2 plus e to the negative 3 ln 2 to the negative 1/2. I'm just going to deal with this first. E to the 3 ln 2 is equal to e to the ln 6, or ln 8, right? Because I can put it as an exponent, which is probably the best way to do this. So that's 8 minus, no, not minus, plus 1 over 8, right? Because 2 to the negative 3rd power is 1/8, right? The negative 1/2 times 1/2. Now let me do this one. Actually, it'll be this, it won't be the same thing, but it'll be 3 times 8 minus 1/8, right? Is that it? Yeah, that should be it. Okay. So then it's 3 over 2 times 8 plus 1 over 8 would be 65 over 8. So square root 65 over square root 8 times 3 times 65 over square root 8. No, there's no square root. So 65 over 8. Okay, what would be the best way to go about doing this? I could do 9. I could make that 2. Okay, I think the best way to do this is to not mess with the square roots and just say 9 times 65 to the 3 over 2 over 2 times 8 to the 3 over 2. That should be it. Okay.
That's what I got, but the answer key was like something really weird.
Interesting.
It was 40 times 82 to the negative.
Okay, so what I'm thinking is they tried simplifying it, which is okay. So I'm assuming they turned this into 2 root 2 and then 0. What is 65 divided by 5? That's 15. Oh, okay. So this is wait, is it 15? Yeah, it's 15. So it's 5 times 5 times 3. That doesn't sound right. Am I doing something wrong here? Because 25 times 3 is not 65, unless I'm tripping. What's 65 divided by 5?
Wait, one. Oh, at 13.
13. Okay. I'm. Wait. Yeah. Okay. I'm stupid. Wait. Hold up. It's. Oh yeah, it's 13. Okay, so it's 13. So that's 5 times 13. Those are both prime numbers, so that doesn't help us out. So 65 to the 3 over 2 is kind of just stuck. And then 8 to the 3 over 2 becomes 2 root 2 times 8. So that's 3 over 4 times 8, 32 root 2. I guess you could do 3 over 32 times 65 cubed over 2, the square root of that. That still doesn't seem like it would help. What was the answer? Oh, it says right there. 40 times 8.
Yeah.
40 times 82. If you plug it into your calculator, do you get the same thing both ways? With the answer we got and the actual answer? Did you try plugging it in?
I have not tried.
Okay, could you try that real quick? I would too, but I don't have my calculator on me.
Yeah. I did not.
They're not the same?
Yeah.
Okay, try plugging in that problem into your calculator. Do you know how to do that?
I do not.
Okay, it should be press F3.
But
Oh, do you have a TI-89?
I do.
Okay.
Yeah, okay. Is that 3?
And then there should be a derivative thing in the menu.
Yeah.
Okay, and then press enter.
Yeah.
And then type in your function, and then comma x, comma the point you want to take the derivative at, which is ln2.
Wait, how do I type E on it?
Oh,
I
yeah, diamond, and then one of them has e to the power.
I found it, yeah. E to the Hmm?
What does it say? Or did it work?
Yeah, it did work.
Did it?
It's something really weird. It says -3 e to the power of 3x over 2 times e to the 6x minus 1 over.
Oh,
Oh, wait, I think, yeah, never mind. I typed in the wrong function.
oh, also, after you do comma x, like at the end of your expression when you take the derivative, you put your
Yeah.
expression, comma x, and then put comma, and then whatever point you want, and it'll just compute it straight. So x,
Oh, really?
comma, ln 2, yeah.
ln2. Wait, can you use ln on this calculator?
Yeah, yeah, it's somewhere. Should be near like the D-pad. I forget exactly.
Hello. I found it.
Okay, yeah, it's right under home, actually.
Oh. It just says domain error.
Okay, let me try plugging it in. Differentiate. Shoot, I have to type this whole thing out. Okay. Oh, try putting times in between, so 3 times x instead of 3x. Sometimes it gets confused.
Okay, I got you. It still says domain error.
Okay. Okay, comma x. Oh, yeah, I'm getting domain error too. What?
This problem, man.
What? Okay, there's no way this is a domain error. Okay, let me try not doing the comma ln2 and just getting it straight and then plugging in ln2. Maybe that'll help.
Okay.
There's Kosh. What? Okay. Okay, now I'm getting a number. I don't know why it says domain error. But it's a really weird number. I don't think it's either of these. Let me see. 40 times 8. Yeah, it's neither of these. Okay. Okay, whoa. 9. Okay, maybe I'm doing something wrong. 9 over 2 times 65 divided by 8. Yeah, okay, I'm getting none of these. What? Okay, let me reread the question. If y is equal to that, then dy dx at x equals ln 2. Interesting. What? And it says domain error when I try and do it here. Oh, well, okay. Oh, it's because ln2 is is it a negative number? It is, right? Because e is 2.7, so it's some kind of negative number.
Yeah.
Okay, so that it's probably messing up with the calculator a little bit, but still, you can plug in negative numbers in here, and you should be fine. What? Okay. If y is equal to that, then dy dx at x equals ln 2.
Okay, anyone else asked about this problem earlier?
No. Yeah, okay. I mean, you might have to
You
have.
might tell us to skip it. I'm not paying attention.
Okay, maybe. But even then, like even the calculator's being weird, which means there's probably something up. Let me try integrating what I got for my derivative and seeing if that does something. Oh, wait. No, that doesn't work. Okay. Integrate. E to the 3x. Wait, 3 times e. Okay, alright. My calculator is being weird, so my last resort is Wolfram Alpha. Let's see. There's no way that's that. Okay. E. Okay, dy dx of what is it? What is it again? E to the
E to the power of 3x plus e to the power of negative 3x, all to the power of 1/2.
okay, e to the power 3x plus e to the power of negative 3.
3x. Yeah.
Okay, and then let me put this all at 1/2. Okay, so 3 over 2. Okay, what did we get? Okay, 3 over 2.
3 over 2. Yeah.
E to the negative 3x, yeah, and then e to the 6x minus 1. Okay, so Wolfram Alpha got what we got.
Oh.
Okay, they got that. Oops.
Okay.
89. Is that the same as ours? Is that the same? That has to be the same as ours, right? Let me see.
Probably, wait. 32. Did you square roots on a graphing calculator, by the way?
Yeah, it's right. It's above the
Oh, I
times
see, I
symbol.
see.
Yeah.
Slightly different.
Okay.
What? 3 over 32 square root
Is there a
of
work for this? Oh, you know why? Okay, so this is a little quirk of Wolfram Alpha is that it doesn't know what ln is. It thinks it only knows what log is. So it's a little weird like that, which is okay. I don't know. This I feel like ours has to be right. Like there's no way.
There's no way.
3 over like none of
I
these.
don't know. I literally just found like 5 times. If you had done my math wrong.
Okay, I think we just might have to ask Mr. Shadow on this.
Okay, that's fair.
Okay, so ask Mr. Shadow on this one and the one with no solution, because that one also makes no sense. Okay. All right. What else? What else?
That's all I got.
Oh, okay.
All right, see ya, Sid.
All right. See ya. All right. That's cool. All right. See ya.